Hi, and welcome to the very first lesson in AP Calculus. Today we're going to be talking about lines and slope and reviewing some concepts that really are the foundation for some of the things that we're going to be doing later on in the course. And you might not think that slope is a big deal or that linear equations are too basic and why are we doing this in calculus. And you'd be surprised at the connection that we're going to be making between slope and some other higher level thinking and higher level concepts. Slope plays a big part in this course as slope defines or describes the rate of change of a function. And really, if you think about there are three main branches of calculus. You've got the area that we're going to start with here soon, describing limits. And then we're going to move into describing rates of change of function, which is why we're going to review slope today. And then later on, we're going to review area and things like, or talk about area, and that's later in the course. So there's really three main branches, and we call them limits, derivatives, and integrals. And so we're going to review this concept of slope because it's a huge deal later on in the course. And we also need to know how to write equations of lines because at some point we're going to talk about what it means to be a tangent line, and we're going to need to determine the slope and a point where we can write the equation of a tangent line to any curve that we're given. So let's talk a little bit about what slope is. Usually when we talk about slope, we talk about rise over run, we talk about the change in y over the change in x, but really what slope is it's a rate of change. And when we have a linear function, so for example, if you have a vehicle moving at a constant speed down the highway, we can measure its distance over time. And the slope of the equation that would describe the motion of that vehicle would be the velocity or the speed of the vehicle moving down the road. And assuming that it's constant, let's say you're going 65 miles an hour, really you can think of that as a fraction. The change that you can expect to see in your position is 65 miles for every 1 hour that you travel. So that's what a rate of change is. It's describing what's happening in the real world. And the equation that we use to describe that is given down here. We've got rise over run. We've got this change in y over the change in x. And that little triangle that is up there, that is a Greek letter called delta, and it means the change in. And the equation that we're used to seeing to find slope is this y2 minus y1 over x2 minus x1. Now, this is what we're going to be using to find the equation of the slope of a line. Now, remember, I said we can also use slope to describe a function that is not linear, a function that is a curve. And what we can do is we can actually use this to estimate the rate of change or to estimate the slope of a curve. So suppose we do have a parabola and it passes through 2 points. If we find the slope between those 2 points, we're estimating the rate of change or the average rate of change over that interval for that nonlinear function. So we're estimating the slope of a curve using the slope of a line. So let's talk a little bit about how we would use this equation. Now, as long as the line is not a vertical line, this formula is the formula for our slope. But what happens when we have a line that's vertical? Well, it's going to look a little bit like this. So suppose we have this vertical line, and this vertical line is going to pass through 2 points. Now, when you have a vertical line, the x-coordinates are the same. So suppose we're going to pass through these 2 points, 1, 2, and 1, 9. The slope of this line would look like this, 9 minus 2 over 1 minus 1, or 7 over 0. Well, that's an undefined value. So when we have a vertical line, the slope formula yields something that's undefined. We can't divide by 0. So we just say that the slope of a vertical line has an undefined slope. And that's important to remember. Now, what happens when we have a line that's horizontal? Well, if we have a line that's horizontal, what happens is my y-coordinates are the same. So suppose I have this point, 2, 4, and 6, 4. Well, when I go to find this slope, it ends up being 4 minus 4 over 6 minus 2. We get 0 over 4, which is 0. So in a horizontal line, the slope is 0. Now, let's also talk about what these equations look like. So we can review what a horizontal and what a vertical line equation might look like. Now you'll notice that when the vertical line, the purple line up here, the x-coordinates were always the same. It didn't matter what the y-coordinate was. So when we express the equation of a vertical line, we express it in terms of x. We say x equals, and then whatever the x coordinate is. So there's my vertical line. Because x will be constant in a vertical line. Horizontal line, this thinking is the same way, except it's the y coordinate that's the same. So this equation has y equals 4. So that's a little review of vertical and horizontal lines. Now let's take a look at what happens when we have a line that's not vertical or horizontal, when we need to write the equation of a line. And as we go throughout this, I'm going to have some AP exam pro tips to help you prepare for the AP exam. I know it's early and the exam is way off, and this is the very first lesson, but it's never too early to start thinking about how can I be successful when I take that AP exam. So let's take a look at the equation that we're going to be using to write equations of lines. This is called point-slope form, and I know that previously in other math classes you may have learned other forms like standard form. Standard form looks like this: ax plus by equals c, where a, b, and c can't be fractions. They have to be integer values. So this is standard form. You may have also learned y equals mx plus b, which is called slope-intercept form. We're actually going to see that a little bit later on down the slide here. But we're going to focus primarily on point-slope form. And the reason we do this is because it's the easiest one to use. And in AP Calculus, we don't have to simplify our answers unless we're explicitly asked to do that. Now, there's some reasonable simplification that we're asked to do, like evaluating unit circle trig values and things like that. But when it comes to writing an equation of a line, as long as it's an equivalent form, you'll get credit for it, unless you're specifically told that you need to write it a certain way. So, in general, we're going to use point-slope form, and then we're just going to plop our values in and walk away. So, suppose a line passes through these 2 points. We want to write the equation of this line in point-slope form. So, I'm going to start by finding the slope. So 2, 5, and -1, 3. My slope is going to be y1 or y2 minus y1. So I'm going to label these x2, y2. So it doesn't matter how you label them. I just labeled them that way because that's the way they appeared. 3 minus 5 over -1 minus 2. That gives me -2 over -3, which simplifies to positive 2/3. So there's my slope. Now I can pick either one of the points and just plop it in. It doesn't matter which point I pick, I'll get an equivalent line. And if you don't believe me, try it with both points, graph it in your graphing calculator, and you'll see that it does give you the same line. So I'm going to plop everything in. So it says y minus y1. I'm going to use the first point because it's first, and that's the only reason why I'm choosing the first point. Y minus 5 equals 2/3. And then it says x minus x1. So x1 is positive 2, so x minus 2. So there's my point-slope form, and I'm going to circle that and walk away. And so here's that AP exam pro tip. Unless you are asked to solve an equation for y, don't do it. Just leave it alone. And you're going to see in just a moment, because we are going to solve this one for y just for the practice, you're going to see that there's 2 reasons why you should not do more work than you are asked to do. Number 1, your exams and your AP exam are always timed. So you want to make sure that you're doing anything and everything you can to maximize your time and to use it wisely to solve as many problems as you can and glean those points. Now, the second reason why you don't want to simplify is because you're going to see in a moment that when we start doing more algebraic steps, you're going to get so bogged down with the higher level thinking in the calculus later on in the course that you find yourself making little mistakes, little arithmetic errors. You multiply your fractions wrong. You add your fractions wrong. You subtract instead of adding. All these dumb little mistakes. And when you try to do more than you need to do, you're opening yourself up to make those mistakes. And I know that we can all do those things. We can all add fractions. We can all multiply. We can all, do the arithmetic and do the mental math. But when you're doing so many steps in a problem, it's very easy to have that mental math go by the wayside. And if I ask you to tell me if you've ever made a mistake, and some of you say, no, I've never, then I know you're lying, because we've all done it, myself included. You'll see in just a moment. So let's go ahead and solve for y, and we'll see what kind of mistakes are fairly common in problems like these. So to solve this equation for y, the first thing I'm going to do is add the 5 over to the other side. So I'm going to get this equation. y equals 2/3 times x minus 2 plus 5. So I just took this 5 and added it to both sides. So now I'm going to distribute my fraction. So I get y equals 2/3 x minus 4/3. And then I'm going to rewrite this 5 as 15/3 because I know I need a common denominator. So my slope-intercept form ends up looking like this: 2/3 x plus, and then I'm going to add the two fractions together, 11/3. So there's my slope-intercept form, and you can see that with all these fractions floating around, it would have been pretty easy to make a mistake. And if I do that, and even if I have the correct answer on my AP exam, or on my test for that matter, somewhere in my work, if my final answer is incorrect, you're not going to get full credit for that final answer. So make sure that you're not doing more than you need to. So now we're going to move on, and we're going to talk a little bit about other kinds of lines. So this equation that we just got, this y equals 2/3 x plus 11/3, that's the answer I just got. I want to write a new equation for a line that is parallel to this one. So let's review some interesting things about parallel lines. So if I have a parallel line, or two parallel lines, remember the slope describes the slantiness, and so two parallel lines have the same slantiness. And so what's going to happen is they're going to have the same slope. So parallel lines have the same slope. So my equation is going to have a slope of 2/3, and then I want it to pass through the origin. And so what that means is it's going to pass through the point 0, 0. So as I'm writing this new line, I'm going to say y equals 2/3, or sorry, let me back up and use my point slope form. Y minus 0 equals 2/3 x minus 0. So there's my x1 and my y1. And so now, simplifying that, it ends up y equals 2/3 x. Remember that b value in slope-intercept form is your y-intercept. So here our y-intercept is 0 because it's passing through the origin. Now, can we write a line that is perpendicular? So let's talk a little bit about perpendicular lines. Perpendicular lines cross at a 90-degree angle. And so what's happening is whatever the rise and run of my first line is, those flip and become the rise and run, or the run and the rise of the perpendicular line. And furthermore, it's going the opposite way. So remember, a positive slope means that my line is slanting up and to the right. A negative slope means I'm going down and to the right. So I have to change that direction and have that negative slope. If my original line is negative, well then my perpendicular line will have a positive slope. So my new slope for this perpendicular line, which by the way, the symbol for perpendicular is this upside down T value. So that means perpendicular, if you don't want to write out the whole word. So my new slope is going to be -3/2, and I'm going to pass through this line, or this point. So I'm going to say y minus the y1 value, so the y coordinate of 7, -3/2 x plus 8. So there is my line that is perpendicular, and it doesn't say solve for y, so I am not going to waste my time doing that. Now, last question, and for this one, I would encourage you to pause the video and give it a try on your own and see if you can solve it. I bet you can. So this says, write the equation of a line that is perpendicular to the line passing through the points 5, 4, and -7, 4, and that passes through the point 2, 1. So go ahead and pause now. Give it a try. So let's see how we do this problem. So first things first, I'm going to find the slope of the line passing through the two given points. So 4 minus 4 over 5 minus -7. 0 over 12. Ooh, this slope is 0. Oh, that means this line must be a horizontal line. And it has the equation y equals 4. Oh, it's a horizontal line. Well, what kind of a line is perpendicular to a horizontal line? A vertical line. So my answer needs to be a vertical line. And it's going to pass through these that point, that 2, 1, which means vertical lines are always of the form x equals the x coordinate. So x equals 2 is the line that is perpendicular to the line passing through these points that passes through 2, 1. So I hope this has been a good little review for you of lines and how they work and slope. Go ahead and move on to the next lesson. And just remember, as we go through these calculus lessons, some of the stuff might seem tough at first, but you can do it. And as long as you stick with it, it's going to be just fine. So keep on going.